how antennas and transmitters work. Hello, engineering enthusiasts. Imagine holding out your H and capturing words, images, and information that pass by. That's more or less what an antenna does. It's the rod or metal dish that captures radio waves and turns them into electrical signals that power something like a radio, television, or telephone system. Antennas like this are sometimes called receivers. A transmitter is a different kind of antenna, an antenna that does the opposite job of a receiver. It transforms electrical signals into radio waves so they can travel sometimes thousands of kilometers around the Earth or even into space and back. That's why antennas and transmitters are the key to practically all forms of modern telecommunications. But how do antennas work? Suppose you are the head of a radio station and you want to broadcast your programs to the whole world. But how do you do that? You use microphones to capture the sounds of people's voices and turn them into electrical energy. You take that electricity and, generally speaking, make it flow along a tall metal antenna, powering it, often, so that it travels as far as you need it to in the world. As the electrons in the electric current swing back and forth along the antenna, they create invisible electromagnetic radiation in the form of radio waves. These waves, partly electric and partly magnetic, travel at the speed of light, carrying your radio program with them. Now, what happens when I turn on my radio at home a few kilometers away? The radio waves you send flow through the metal antenna and make the electrons swing back and forth. This generates an electric current, which, in turn, is converted into a signal that the electronic components inside your radio turn back into sound that can be heard. Transmitting and receiving antennas are usually very similar in design. For example, if you are using something like a satellite phone, which can send and receive a video or phone call to anywhere else on Earth. Using satellites, the signals you transmit and receive, you see, go through a single parabolic antenna. The parabolic antenna is a special type of antenna in the shape of a bowl and is commonly known as a parabolic reflector because the antenna curves in the shape of a graph called a parabola. But transmitters and receivers look very different. TV or radio transmission antennas are huge masts, sometimes extending hundreds of meters into the air, because they need to send powerful signals over long distances. But you don't need anything that big on your TV or radio at home, because a much smaller antenna will do the job just fine. The waves don't always travel through the air from the transmitter to the receiver. It depends on which frequencies we want to transmit, how far we want to send them, and when we want to do it. And what should be the length of an antenna? Is bigger always better? The simplest antenna is a single piece of metal wire attached to the radio. Most modern transistor radios have at least two antennas. One of them is a long, shiny telescopic rod that comes out of the radio and rotates to pick up FM signals, which stands for frequency modulation. The other is an antenna inside the case, usually attached to the main circuit board, and it picks up AM signals, which stands for amplitude modulation. The differences between AM and FM are interesting, so if you want to know more, leave a comment below and we can make a video about it. But why do you need two antennas in a radio? The signals in these different wavebands are carried by radio waves of different frequencies and wavelengths. Typical AM radio signals have a frequency of 1000 kHz, while typical FM signals are about 100 MHz. So they vibrate about 100 times faster. Since all radio waves travel at the same speed as light, which is approximately 300,000 kilometers per second, AM signals have wavelengths about 100 times longer than FM signals. You need two antennas because a single antenna can't pick up such a wide range of wavelengths. It's the wavelength or frequency of the radio waves you're trying to detect that determines the size and type of antenna you need to use. In general terms, the length of a simple antenna has to be about half the wavelength of the radio waves you're trying to receive. But some technologies make it possible to build antennas that are a quarter of the wavelength, compact miniature antennas that are about a tenth of the wavelength, and membrane antennas that are even smaller, although we won't go into detail here. The length of the antenna is not the only thing that affects the wavelengths you will pick up. That's because if we had a radio with a fixed antenna length, it would only be able to receive from one station. The antenna feeds signals into a tuning circuit inside the radio receiver, which is designed to grab a specific frequency and ignore the rest. The simplest receiver circuit is nothing more than a coil of wire, a diode, and a capacitor that feeds sounds into headphones. The circuit responds or resonates at the frequency you are tuned to and discards frequencies higher or lower than that. By adjusting the value of the capacitor, you can change the resonant frequency, and that's what tunes your radio to a different station. The job of the antenna is to capture enough energy from the passing radio waves to make the circuit resonate at the right frequency. The simplest radio antennas are just long, straight rods, sometimes called monopoles. Many indoor TV antennas are shaped like a dipole, a metal rod split into two parts and bent horizontally, so it looks a bit like a person standing with their arms stretched out horizontally. More sophisticated outdoor TV antennas have several of these dipoles arranged along a central support rod. Other designs include circular wire loops and of course satellite dishes. But why are there so many different designs? Obviously, the waves that reach a transmitter antenna are exactly the same no matter the shape or size of the antenna. A different dipole pattern will help focus the signal so that it's easier to detect. This effect can be further enhanced by adding disconnected passive dipoles, known as directors and reflectors, which reflect more of the signal toward the receiving dipoles. They lack the means to complete a circuit in so-called monopoles. Three characteristics of antennas are particularly important, which are their directionality, gain, and bandwidth. Let's start with directionality. Dipoles are very directional. That's because they pick up radio waves that travel at right angles to them. That's why a TV antenna needs to be properly mounted on your house and pointed in the right direction. If you want to get a good picture, nowadays, you don't have much of this problem since TV signals are digital. But back in my day, you had to wrestle with the antenna for a good few minutes before you got a decent picture. The FM radio telescopic antenna is less directional, especially if the signal is strong. If you point it straight up, it will pick up good signals from almost any radio equally. The ferrite AM antenna inside the radio is much more directional. Although highly directional antennas may seem inconvenient, when they are properly aligned, they help reduce interference from stations or unwanted signals near what you are trying to detect. But directionality isn't always a good thing. Think about your cell phone. You want it to be able to receive calls no matter where you are in relation to the nearest cell tower, or pick up messages no matter which way it's facing when it's in your bag. So a highly directional antenna isn't a good thing. The same goes for a GPS receiver that tells you where you are using signals from several satellites. Since the signals come from different satellites in different places in the sky, again, a highly directional antenna wouldn't be useful. The gain of an antenna is a very technical measurement, but generally speaking, it comes down to how much it increases the signal. TVs usually pick up a weak and ghostly signal even without an antenna connected. This happens because the metal case and other components act as a basic antenna, not focused in any specific direction, and they pick up some kind of signal by default. Add a proper directional antenna and you'll get a much better signal. Gain is measured in decibels, and the higher the gain, the better your reception. In the case of TVs, you get much more gain from a complex external antenna than from a simple dipole. All external antennas work better than internal ones, and antennas mounted on windows and in sets have higher gain and work better than built-in ones. The bandwidth of an antenna, on the other hand, is the range of frequencies or wavelengths over which it operates effectively. The greater the bandwidth, the wider the range of different radio waves you can receive. This is useful for something like television, where you may need to receive many different signals, but much less useful for telephone, cellular, or satellite communications, where all you need and are interested in is a very specific radio wave transmission in a rather narrow frequency band. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're looking for personal and professional growth, scan the QR code here on the side or use the link in the video description to gain access to various opportunities to develop several skills that will make a difference in your career. So, what kind of antenna do you have at home? Have you ever struggled with your TV to find the signal? Leave a comment below, I want to know. Right here on the side, there are 2 interesting videos that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave a like, subscribe to the channel, and turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.